He was very. Yeah.
All right. So in the homework assignment on page 19, I want to go over two problems that I think previous class also had questions about these, so you may have as well. I want to go over 63, the diagram problem, and then 33, the amusement park problem. Okay, I'll go over this in detail and see if you guys have any questions after I go through it. Okay. Okay, so 63, this is, let me read the problem here. A pulley with a radius r is being used to remove part of the set of a plate during intermission. The height of the pulley is 12 feet. You see that here. If the radius of the pulley is 6 inches, okay, so 6 inches given here, and it rotates 180 degrees, how high will the object be lifted? So we can list out our information here. We can say we're ultimately looking for, well, the height of the object being lifted is going to correspond with the arc length that is traveled through the pulley. So ultimately, we're looking for variable s. Radius is 6 inches, so r is 6 inches. And it rotates 180 degrees. So we know that theta is 180 degrees. However, we know that the 180 degrees is theta, but is not quite the appropriate unit that we need for our arc length formula, right? Everything has to be in terms of radians, so we got to go through a conversion. We got to multiply it by pi over 180, which is just equal to pi, all right? 180 cancels out, we're left with pi. So that is the radian equivalent of 180 degrees. S equals r theta. Now we just enter into our formula. S is the unknown, r is 6, pi is our theta. Enter in our calculator, round to 3 decimal places, 18.850 inches. Any questions with that? Okay. Part B, very similar setup, but in this case, our radius is 4 inches, so we make that adjustment. Rotates 900 degrees, so instead of 180, we'll do 900 times pi over 180. I have that indicated here. I did not show the decimal value. Well, actually, sorry, this ends up just giving us reduced to be 5 pi. And I just entered all this in the calculator. 900 divided by 180 is just 5. So here's my radius. Here's my theta in terms of radians. And then calculator to 3 decimal places. So I don't think this formula is difficult. However, we do have to keep reminding ourselves that we got to make that additional step for theta if it is not in the correct units, right? So if it's in radians, then keep it in that value. But if it's in degrees, you got to force it through that pi over 180 to get it in the correct form. Otherwise, the formula doesn't work. Okay. Any questions with 63? Okay. Let's go down to 33. A carousel at an amusement park rotates 3,024 degrees per ride. So we know that there are many rotations that this carousel goes through for that ride. Okay, so part A, how far would a rider seated 13 feet from the center? So we have to understand that 13 feet from the center is talking about the radius. Right, radius is a distance from the center of the circle to the outer part of the circle. How far would the rider travel along that circular path? So we're talking about trying to find arc length. So S is the unknown, R is 13. and theta is 3024. Okay. This is degrees, so we have to push it through that conversion, times pi over 180, 52.778. So here's my theta, here's my radius, S equals R times theta, decimal value 686. Okay, so that's part A. Any questions there? Part B, how much farther would a second rider seated 18 feet from the center? So let's say this is a carousel with an outer ring and inner ring. So we have a rider that is further away, which means that it's still going through the same number of rotations, but because it's a larger circular path, we know that this rider is going to travel a further distance, right? So we basically have to figure out the arc length for the second rider. So we take our radius, which is now 18. Theta is still 3024, which is going to be the same conversion, 52.778. The only difference is that now the rider is further away from the center, so it's going to be a longer arc length path. So we get 950.018. So we know how far the second rider travels. We know how far the first rider travels. So now, if we want to find the difference between the two riders, we just subtract the two distances, right? 950 minus 686, we get 263.894. Okay. Does that make sense? Any questions there? Okay. All right, so yesterday we started talking about coterminal angles and reference angles. So if you guys can turn the page. Let me do a little bit of a recap. And then today I just want us to continue working with coterminal and reference angles just to get more comfortable with them. And tomorrow we'll do a full review. Okay, this is page 20. I just want to do a quick recap. So the idea with coterminal angles is that we know that the idea with coterminal angles is that whatever the terminal side is, it could be angle that's 30 degrees. Oops, sorry. Could be a terminal side that's 30 degrees. If we rotate it 360 degrees, it's going to give us a different angle, but that terminal side is going to be the same. The idea is that if we take a terminal side and we keep adding 360 or keep subtracting 360, we're going to have all these angle measures that are all sharing the same coterminal angle because every time we rotate, we're just going to come back to the same location. All right. So if we want to find a positive and a negative coterminal angle, we can simply add or subtract the 360 because these are just variations of the same coterminal angles. And we're able to arrive at a positive and negative angle measure that we can recognize. Okay. So if we have a really large positive angle, we can subtract 360 multiple times until we get to an angle measure that we recognize. And then we can indicate which quadrant that we're in. If I subtract 360 from 80 again, I'm left with a negative angle measure, but these are all the same angle in relation to the circle. They're all going to be sitting in the first quadrant. It's just different variations of rotations and around the circle. Okay. We also talked about reference angles. Sorry, before we do reference angles, let's look at some examples of coterminal angles on page 22. All right, so this will be part of your homework, and we're going to work through some of them together. Page 22. Okay, let's look at number 18 on page 22. I'm going to try to work some of this on a separate sheet just so I can have room to show you all the steps. So you're welcome to put it on a separate sheet or put it on the side just to let you know we may need more room than I'm giving you here. Okay, so this is on page 22. Let's read the directions here. It says, identify all the angles that are coterminal with the given angle. Then find and draw a positive and negative angle coterminal with the given angle. We talked about yesterday how there's going to be infinite number of coterminal angles, right? You can keep adding and subtracting 360, but we're going to be able to find a way to at least create a formula that will allow for us to kind of represent all the coterminal angles for a given angle. So again, we know coterminal angle. We can find coterminal angles by either adding or subtracting 360 or adding or subtracting 2 pi, right, depending on which unit we're in, either degrees or radians. Okay, so that's basically what we want to be able to represent that in a more formal way. So we're going to say 120 degrees. If I want to represent all the possible coterminal angles, I'm going to write it out this way. So 120 degrees, we're going to say plus 360 n, and that just means that we're just going to multiply or add multiples of 360. But we want n to be any positive and negative whole numbers. So technically, we want our n to be an integer. So to indicate what n represents, we'll just say n is an element of an integer. So the notation for integer, kind of strange looking here, it's kind of like a z notation. So that's just to indicate that what n is an element of a value that's an integer. So it could be 300, it could be 2, it could be negative 500. Those are all valid n values. We just want to be able to define what n means. Okay. It could be positive, it could be negative. But these will represent all the possible coterminal angles for 120 degrees. Okay. Next up, it says find and draw one positive and one negative angle coterminal with a given angle. So this is an angle that we recognize. If we didn't recognize this angle, we would subtract or add 360 until we get it into a range that we can clearly visualize on the coordinate or on a graph. Okay, so 120 degrees, we know what that looks like. We know where that is. That angle measure is going to be in the second quadrant. And I'm going to indicate how we're going to get there. 120 degrees is from the initial side to the terminal side. Okay, that's how we get to 120 degrees. All right. Let's create a coterminal angle for that. So let's create a positive version of this. So let's create one more rotation around, since it's asking for one positive, one negative coterminal angle. So we'll do 120 plus 360. And that would be 480. We know it's going to end up in the same spot. So we know our end result is going to be here. We're just going to start at the initial side. And we're just going to go one more rotation around the circle before we reach that destination. Okay, does that make sense? Okay. All right, so we're also going to, so let me box this up here. This is 480 degrees. That's a positive coterminal angle. Now let's create a negative coterminal angle. So I'm going to start with that 120, and now I'm going to subtract 360 from that. So that's negative 240 degrees. We know it's going to end up in the same spot. But now we're always going to start on the initial side, but we're just going to rotate in a clockwise direction, in the opposite direction. So there we go. We all end up in the same spot. We just have different rotations and different directions to get there. Okay, any questions? All right, let's try number 21 together. Let me have you guys try 21, and actually I'll do number 21 with you because 21 has a negative starting point. So I'll do this one with you as well. Let's try 21. Negative 150, we want to create a rule that represents all the possible coterminal angles. So we just follow the same model as what we did above. Okay, if you're looking at that negative 150 and if you don't know exactly where it is, it's okay. We can, let's just add 360 so we can at least recognize where that angle is a little bit more clearly. So I'm just going to put this off to the side here. Negative 150 plus 360 is 210. So that's good. That's actually a coterminal angle that we can use, but I'm going to use that 210 as a way of, as my starting point, since it's easier for us to recognize 210 than it is negative 150. But we're gonna graph all of them. Just let's start here instead of negative 150. Okay, just easier to identify that. Okay, so 210, where is that going to be? Which quadrant is that? Third, right? We know 180 is here, 270 is here, so that's 210 is somewhere between 180 and 270. Okay, let me draw the path that takes us there. Start on the initial side, go in the positive direction. Okay, there's my 210. Let's do the original one, negative 150. We now know where it is. We just have to draw our movement from the initial side to that angle measure. So to get to that negative 150 degree, we're going to start on the initial side and we're going to go this direction here. So this is measure of negative 150, 210. Okay. So this is the original, but we started with the coterminal angle because it's just easier to recognize. So we have a positive coterminal. Let's create a negative coterminal. So I can subtract 360 from 150. And I get negative 510. Okay, we know where that angle, where that terminal side is going to be. It's going to be in that third quadrant. But we know it's going to be negative 150, and then with another full rotation in the negative direction. So start on the initial side, work our way around, and then end up on the same terminal side. Okay, questions with 21. All right, so we see it from a degree perspective. Let's look at this from a radian perspective. So let's look at number 22. Does anybody still need to look at 21? Okay, 22. Okay, 22 pi over 3. If you don't recognize this angle, you can always convert it to a degree measure until, I mean, down the road, we're going to kind of train ourselves so we can kind of recognize what these angles are. But in the meantime, we can always use conversion to help us get to degree measure, which we just, I know, naturally just have the easier time with. But if you don't know what that is, divide or go through the conversion process, 180 over pi. And we know that is talking about 60 degrees. Okay, so just to kind of have an idea where it is, which quadrant it's going to be, and then we can always come back to that pi over 3. Okay, let's write our all the rule for all the possible coterminal angles. So that means we're going to start at pi over 3. Instead of adding and subtracting 360, we're going to add and subtract 2 pi. But the way that we're going to say it is plus 2 pi n to indicate that all the positive and negative rotations are in play. And then our n value is still going to be within the set of all possible integers. Yes, question.
What is like the E?
Okay, so we know that n is an element of integers. So that just indicates that an n value that we can choose, it has to be an integer value.
So like on the test would be that at the top.
If I'm going to ask you for this notation, okay, this won't be on the quiz, but if it is on the test, I will definitely indicate what form I want it to be. But right now, I don't foresee this to be something that I'm going to expect unless I specifically ask for it. Okay, so but right now, at least you're able to be introduced to some of these notations and understand what it means. But thanks for asking. Yeah, that means that n is an element of an integer. Okay, so pi over 3, 60 degrees, we can safely say that's in the first quadrant. We're going to create a coterminal angle that is a positive and a negative version of this. So let's do a positive version of it. I'm going to add 2 pi. If I want to get this to be, you can, if you use your calculator, you can say 1/3 plus 2, leave the pi out of the calculator. Or without a calculator, I can say pi over 3 plus matching with common denominator, 6 pi over 3. So that means I'm going to start at 60 degrees, or pi over 3. I'm going to do another full rotation before I reach that coterminal side. So I reach pi over 3. I'm going to do another rotation around. Okay, questions? All right, we have a positive coterminal. Now let's find a negative coterminal. So I'm going to start at pi over 3 and subtract 2 pi. So common denominator. There's my coterminal angle in terms of radians. I know where it's going to land. I know it's going to be in the first quadrant, which is going to show my path to that terminal side. So start at the start on your initial side. Now we got to go in the negative direction. Got to go clockwise. Okay, how are we doing? Any questions? Okay. Okay, so that'll be part of your homework tonight. But I want to at least do a few of them so that you feel comfortable enough to finish the rest of it. But now I want to move on to reference angles. Yes, question.
Sorry, for the homework, do we have to draw the like graph sort of thing? Or?
Oh yeah, because I haven't.
Yes, I want you to draw them out so that you can practice showing the rotations there. Okay, yeah, go ahead.
Just doing page 22, or as we also.
22, that's the first half, but I want to. It's also 23 as well. We're gonna work on those.
But we're not doing the word problem.
Yeah, that's right. We can skip the word problem. Okay. Yeah, I want us to practice drawing these out. This will also be kind of a good foundation for us to, as we move into other more complex problems later on. Okay. Let's turn to page 23. Okay, I want to highlight some notes from yesterday just to kind of give a recap of reference angles before we jump into them. Okay, so here is what I went over with reference angles. The idea with reference angles is that depending on where your terminal side is, our reference angle is always going to be that angle measure between the terminal side and the closest x-axis that you see. So if your terminal side is in the first quadrant, then your angle is the reference angle. There's nothing more you have to worry about. If you see 60 degrees here, your reference angle is 60 degrees because reference angle just has to be positive and has to be between 0 and 90 degrees. Okay, I'll talk about radians a little bit later. Let's just review degrees first. If your terminal side lands in the second quadrant, then if I ask you for the reference angle, then I'm asking you for that angle measure between the terminal side and the x-axis here. Now, the way that you can find that angle measure is you can involve subtracting with 180. Okay. 180 minus whatever that angle is, let's say it's 150, then that will get you a reference angle that is not only positive, but lands nicely between 0 and 90. It has to be a degree measure that is an acute angle between 0 and 90. If your terminal side lands in the third quadrant, then your reference angle is going to be that measure between that terminal side and the x-axis. Again, you're going to be involving subtracting from with 180 to arrive at that angle measure. And finally, if your terminal side lands in the fourth quadrant, then your reference angle is just going to be that measure there. And the way that you can find that measure is you can subtract from 360. So this is 300 degrees. You will do 360 minus 300, and that will give you a reference angle that's 60, which is in that range that we're looking for. Okay. So that's the easier one with degrees. The adjustment with radians is instead of, if it's in the second or third quadrant, instead of subtracting from one or involving 180, you're going to subtract involving pi. If you're in the fourth quadrant, instead of subtracting from 360, you're going to subtract from 2 pi. And if you're in the first quadrant, then whatever the angle measure is in the first quadrant, that's going to be the same as your reference angle. So no need to adjust if your terminal side is in the first quadrant. So with that in mind, let's do a couple of practice problems, and which will be part of your homework as well, 17 through 24. This is on page 23. Let's start with 17. Sketch each angle, then find its reference angle. Okay, so initially, these angles are going to be something that we recognize, okay, that we can instantly plot onto and decide which quadrant it's in. But if an angle measure doesn't land as nicely as we would want it to, then we would find a coterminal angle that would fit in that 0 to 360 range, and then we can go on from there. Okay, but let's start off with something a little bit more straightforward. Let's start with 17. Okay, we want to find the reference angle, but let's go ahead and draw the angle, identify the quadrant so we can visualize it so that we can make a decision as how to or what to involve to find our reference angle. So 135 degrees, which quadrant is this in? Second, okay. So let's go ahead and get that to show up. So if my angle is in the second quadrant, I want to find a reference angle, I have to involve the closest x-axis. Make sure that you're always involving the x-axis. Never find the angle measure with the y-axis. That's not reference angle. Okay, has to be between your angle, your terminal side, and your x-axis, closest x-axis. I'm going to call that theta prime. This is in degrees. We know this is 180 degrees, so we simply subtract those two values, and that's our reference angle. .45 degrees. Okay, any questions there? Okay. I'm going to go down this column here. Let's try number 19. So we're going to shift our focus here. Now we're dealing with radians. So if you see something in radians, you may not instantly know where that is going to land in terms of the quadrant. So it's okay. Just go through and convert it to be in terms of degrees so that at least you can have an idea where it's going to land in terms of which quadrant. So I'll do a quick conversion so I can have a better idea. Multiply by 180 over pi. Clean that up. 7 times 180 divided by 12. The pi's cancel out. So that's enough for us to make a distinction as to where it is. 105 degrees, that's going to be in the second quadrant. So we can go ahead and place that there. Same idea. We know we have to involve the closest x-axis. Instead of subtracting from 180, I'm going to subtract from pi. To get my theta, my reference angle in terms of radians. So 1 pi minus 7 pi over 12. You can use your calculator, 1 minus 7/12, or common denominator, work it out by hand. 5 pi over 12. Okay. We know that our reference angle in terms of degrees has to fall between 0 and 90 degrees.
Right, if I got -1.5.
Did you enter pi in the calculator?
Yeah.
Yeah, leave pi out of it. Okay, just add it to your fraction when you find it. So 5 pi over 12, this actually is going to be safely in our region because in terms of radians, as long as we're between pi over 2 and 0, if you think about 5 over 12, that's less than 1/2, right? 6 over 12 is 1/2. 5 over 12 is less than 1/2. So 5 over 12 is going to land nicely in this region. That's enough for us to say that's a safe value for my reference angle. Okay, so not only do we have to be comfortable, so a couple of things, right? We have to know what reference angles are. We have to be able to identify where that angle is. If it's not a degree measure that we recognize, we have to add or subtract 360 until we can identify where that terminal side is. And then we also have to be able to do that in terms of radians. Okay. If you don't recognize the radian measure, then convert it to degrees. And so we kind of have to get comfortable, going back and forth and be able to work it from all of those different perspectives. Okay, questions with 19. Okay, all right, let's try number 21. All right, so -405, that's not an angle that we can easily recognize. So what could we do to help us graph it? Yeah, at 360, right? And if that doesn't get you to where you need to go, then add another 360. Okay, try that. So the first thing that we want to do is we want to know where that angle is so that we know which quadrant it's in. And if we know which quadrant it's in, we'll have a better idea as to. Okay. -405, let's see. -405 plus 360 is -45. So -45 is not in the first quadrant, right? Well, if you don't recognize that -45, then keep adding 360. So get it to so that it's nicely between 0 and 360, and then you should be able to make a cleaner read. I know right now that -45 doesn't.
315.
Yeah.
Which is the 40.
There we go. Okay. Yes, it is. Okay, so once you're there, now you can know how to make progress, right? I have a degree measure. It's in the fourth quadrant. So to find my reference angle, I got to involve my x-axis, closest x-axis. So that means I have to subtract from 360. That's going to help me get to my reference angle. Okay, questions? Okay, let's do 2 more from this page. You're essentially doing your homework problem here, but let's do 22 and 24. I just want to see if we can get more comfortable with all the steps that are involved. So 22 and 24, try those 2. Now, I saw some students do this in 5th period. You're welcome to do this as well. If you start with radians, you got to end with radians. But what some students have done is they would convert to degrees, do all their intermediate steps in terms of degrees, and at the very end, go back to radians. You can do that as well. Right, so you have some options. If you want to do everything in degrees, and then at the end, shift it back to be in terms of radians, you can do that. Feel free to try other problems as well as part of your homework. I will go over both these problems in a bit, but want to make sure everyone has a chance to try it. But if you think you're done, continue finishing up on your homework problems. So again, your homework problems are going to be page 22, 18 through 25, and then page 23, 17 through 24, and we've worked through a bunch of them. Okay, here's 22. So the first thing that we need to do is, if you don't recognize that -75, add 360, right? Get it to a degree measure between 0 and 360. 285 is going to be slightly in the 4th quadrant there. We know 270 is here, so 285 is here. So once you can put it in the correct quadrant, you'll know what number to involve. Got to involve 360 there. 360 minus 285. 75 degrees. Double check, your reference angle has to be a positive number, which it is. It's also between 0 and 90, which it is. We started with degree measure, so you'll represent your reference angle in degree measure as well. All right, try 24 if you haven't done that already. If you don't recognize 13 pi over 6, feel free to convert it to a degree measure. You can do everything in degree measure and shift it back to radians if you'd like. All right, so 24, 13 pi over 6, maybe you don't recognize that, so multiply by 180 over pi, and then 390, that's something that we recognize a bit more, right? We know it's a degree measure, we know it's greater than 360, so if you want to subtract 360 to get it to something that you recognize, that's 30 degrees. Okay. You know 30 degrees is in the first quadrant. So that's already the reference angle that we need. So our answer is 30 degrees, but we started with radians, so you got to bring it back in terms of radians as well. So reference angle theta prime is pi over 6. Again, if you want to do.
I did that, I just didn't collapse it. I kept it at like 180 pi over 30.
Okay. Yeah, so make sure that whatever answer you have, you bring it back to the units that you started with. Okay. If you want to do all your intermediate steps in degrees, that's fine. Good. I'm glad that we have this extra day to kind of just focus on coterminal angles and reference angles. These are the problems that a little bit more involved because of the variety of ways that we can approach based on what is given in the problem. So tomorrow we'll be able to do a full quiz review. Okay, your quiz is also going to have one word problem. Okay, and that word problem is going to be the double triangle problem that we did right after the quiz. So we'll practice a couple of those, and we'll come back and review. Question?
Good afternoon, Nelson Eagles. The following are the bus changes